Functions. Learning objectives. In this chapter, the user would learn the following in detail. Top-down approach of problem solving, modular programming and functions, standard library of C functions, prototype of a function, formal parameter list, return type, function call block structure, passing arguments to a function, call by reference, call by value, recursive functions, arrays as function arguments. Functions. There are three general approaches to writing a program: top-down, bottom-up, ad hoc. The top-down approach. In the top-down approach, one starts with the top-level routine and move down to the low-level routine. Top-down approach example. Top-down approach of problem solving. A top-down approach also helps one to clarify the overall structure and operations of the program before one code the low-level functions. The top-down method starts with a general description and works towards specifics. In fact, a good way to design a program is to define exactly what the program is going to do at the top level. Each entry in the list should contain only one function unit. A functional unit can be thought of as a black box that performs a single task. Modular programming. Modular programming is a style that adds structure and readability to the program code. It may not make much difference on small projects, but as one starts to work on something bigger, it can make the code much easier to read and maintain. Structuring the code is a simple task of splitting the program into manageable chunks so that each part is self-contained. By creating these self-contained modules, one can focus on programming each part. Once one is satisfied that one bit is working, one can then move to the next module with the confidence whatever one does elsewhere will not have an effect on the other modules that one has already written. Modular programming example. Functions. What is a function? A function is a named, independent section of C code that performs a specific task and optionally returns a value to the calling program. A function is named. Each function has a unique name. By using the name in another part of the program, one can execute the statements contained in the function. This is known as calling the function. A function can be called from within any other function. A function is independent. A function can perform its task without interference from or interfering with other parts of the program. General form of function. The relational operator. The relational operators are used to compare expressions, asking questions such as, is y greater than 100 or is z equal to 0? An expression containing a relational operator evaluates to either true 1 or false 0. True is considered the same as yes, which is also considered the same as 1. False is considered the same as no, which is considered the same as 0. An expression created using a relational operator forms what is known as a relational expression or a condition. C's relational operators are as follows: less than or equal to, greater than or equal to, not equal to. Logical operators. Introduction. Logical operators let the users combine two or more relational expressions into a single expression that evaluates to either true or false. Logical operators consist of and, or, and, not as shown. An expression containing a logical operator evaluates to either true 1 or false 0. True is considered the same as yes, which is also considered the same as 1. False is considered the same as no, which is also considered the same as 0. Standard C library. A collection of reusable functions, code for building data structures, code for performing math functions and scientific calculations, etc., which will save C programmers time, especially when working on large programming projects. The C library is part of the ANSI, American National Standard Institute for the C language. The C programs can call on a large number of functions from the standard C library. These functions perform essential services such as input and output. They also provide efficient implementations of frequently used operations. Many macros and type definitions accompany these functions and help them to make better use of the standard C functions. Standard library of C functions. C standard library functions, or simply C library functions, are inbuilt functions in C programming. Function, prototype, and data definitions of these functions are written in their respective header file. For example, if you want to use printf open close bracket function, the header file stdio.h should be included. There is at least one function in any C program, that is the main function, which is also a library function. The program is called @ProgramStarts. There are many library functions available in C programming to help the programmer to write a good, efficient program. Suppose you want to find the square root of a number. You can write your own piece of code to find square root, but this process is time consuming and the code you have written may not be the most efficient process to find square root. But in C programming, you can find the square root by just using sqrt open close bracket function, which is defined under header file open quote math.h close quote. Use of library function to find square root. Computes the square root of num and stores in root. Listed below are few of the standard C libraries. stdio.h supports file input-output operations. stdlib.h supports miscellaneous declarations. math.h supports definitions used for mathematical calculations. string.h supports string functions. time.h supports system time functions. ctype.h header file ctype.h include numerous standard library functions to handle characters, especially test characters. Example programs of frequently used standard C libraries. Function prototype. Return type function name open bracket arg hyphen type name hyphen 1 arg hyphen type name hyphen n close bracket close quote. A function prototype provides the compiler with the description of a function that will be defined at a later point in the program. The prototype includes a return type indicating the type of variable that the function will return. It also includes the function name, which should describe what the function does. The prototype also contains the variable types of the arguments, arg type, that will be passed to the function. Optionally, it can contain the names of the variables that will be passed. A prototype should always end with a semicolon. Double square D, double number. void print underscore report, open bracket, interport underscore number, close bracket, semicolon. Int get menu choice, open bracket, void, close bracket, semicolon. Prototype function. Function definition. A function definition is the actual function. The definition contains the code that will be executed. The first line of a function definition, called the function header, should be identical to the function prototype with the exception of the semicolon. A function header shouldn't end with a semicolon. In addition, although the argument variable names the optional in the prototype, they must be included in the function header. Following the header is the function body, containing the statements that the function will perform. The function body should start with an opening bracket and end with a closing bracket. If the function return type is anything other than void, a return statement should be included, returning a value matching the return type. Function definition program. Parameter. A parameter is a special kind of variable used in a subroutine to refer to one of the pieces of data provided as input to the subroutine. These pieces of data are called arguments. Parameter means values supplied to function so that function can utilize these values. Parameters are simply variables. Difference between normal variable and parameter is that these arguments are defined at the time of calling function. Formal parameter. Parameter written in function definition is called formal parameter. Although formal parameters are always variables, actual parameters do not have to be variables. Actual parameter. Parameter written in function call is called actual parameter. One can use numbers, expressions, or even function calls as actual parameters. Example: void main open close bracket int num1 display open bracket num1 close bracket semicolon. Void display open bracket int space para1 close bracket. num1 is called actual parameter. Parameter list. A function is declared in the following manner: return type function name open bracket parameter list, comma and so on close bracket open bracket body and so on close bracket. Return type is the variable type that the function returns. This cannot be an array type or a function type. If not given, then int is assumed. Function name is the name of the function. The function return type. The function return type specifies the data type that the function returns to the calling program. The return type can be of any C's data types: char, int, long, float, or double. One can also define a function that does not return a value by using a return type of void. Give a few examples. Return type program. Calling functions. There are two ways to call a function. Any function can be called by simply using its name and argument list alone in a statement, as in the following example. If the function has a return value, it is discarded. Wait, open bracket 12, close bracket, semicolon. The second method can be used only with functions that have a return value. because these functions evaluate to a value, open bracket, that is, their return value, close bracket. They are valid C expressions and can be used anywhere as a C expression can be used. Calling functions. An expression with a return value used as the right side of an assignment statement. Here are some examples. In the following example, half of is a parameter of a function printf. Open bracket, open quote. Half of %d is %d, close quote, comma, x, comma, half underscore of, open bracket, x, close bracket, semicolon. First, the function half underscore of, open close bracket, is called with the value of x, and then printf, open close bracket, is called using the values of x and half underscore of x. In this second example, multiple functions are being used in an expression :y is equal to half underscore of, open bracket, x, close bracket, plus half underscore of, open bracket, z, close bracket, semicolon. Although half underscore of, open close bracket, is used twice, the second call could have been any other function. The following code shows the same statement but not all on one line. A is equal to half underscore of x, B is equal to half underscore of z, Y is equal to A plus B. Block structure. A program is made up of one or more functions, with one of these being main, open close bracket. Function is a self-contained block of program that performs a particular task. This is called the structure of function. Example of block structure of program. How to create blocks using open close bracket and their significance. Passing arguments to a function. To pass arguments to a function, list them in parentheses following function name. The number of arguments and the type of each argument must match the parameters in the function header and prototype. For example, if a function is defined to take two type int arguments, one must pass it exactly two int arguments, no more, no less, and no other type. If one tries to pass a function an incorrect number and or type argument, the compiler will detect it based on the information in the function prototype. If the function takes multiple arguments, the arguments listed in the function call are assigned to the function parameters in order. The first argument to the first parameter, the second argument to the second parameter, and so on. Multiple arguments are assigned to function parameters in order. Each argument can be any valid C expression, a constant, a variable, a mathematical or logical expression, or even another function, one with a return value. For example, if half, square, and third are all functions with return values, one could write as follows: x is equal to half, open bracket, third, open bracket, square, open bracket, half, open bracket, y, close bracket, close bracket, close bracket, close bracket, semicolon. The program first calls half, open, close bracket, passing it y as an argument. When execution returns from half, open, close bracket, comma, the program calls square, open, close bracket, comma, passing half, open, close bracket, return value as an argument. Next, third, open, close bracket is called with square, open, close bracket, squares, return value as the argument. Then half, open, close bracket with third, open close bracket, apostrophe s, return value as an argument. Finally, half, open close bracket, apostrophe s, return value is assigned to the variable x. The following is an equivalent piece of code. A is equal to half, open bracket y, close bracket, semicolon. B is equal to square, open bracket A, close bracket A, semicolon. C is equal to third, open bracket B, close bracket, semicolon. X is equal to half, open bracket C, close bracket, semicolon. Call by reference. In this method, the address of an argument is copied into the parameter. Inside the subroutine, the address is used to access the actual argument used in the call. This means that the change made to the parameter affects the variable used to call the subroutine. The address of x and y are passed as the parameter to the function swap, open close bracket. Call by reference. Example. Call by value. This method copies value of argument into the formal parameter of the subroutine. Therefore, changes made to the parameters of the subroutines have no effect on the variable used to call it. The value of t is passed as the parameter to the function swap, open and close bracket. Call by value program. Recursive functions. Recursion. The term recursion refers to a situation in which a function calls itself either directly or indirect. Indirect recursion occurs when one function calls another function that then calls the first function. C allows recursive functions and they can be useful in some situations. For example, recursion can be used to calculate the factorial of a number as shown. The following program demonstrates recursive function. Recursive and non-recursive functions. Arrays as function arguments. An argument is a value that the calling program passes to a function. It can be an int, a float, or any other simple data type, but it must be a single numerical value. It can be a single array element, but it can't be an entire array. One can have a pointer to an array, and that pointer is a single numeric value, the address of the array's first element. If one passes that value to a function, the function knows the address of the array and can access the array elements using pointer notation. Int largest, open bracket, int into open close bracket, comma, int y. The largest open close bracket is a function that returns an int to the calling program. Its second argument is an int represented by the parameter y. The only thing new is the first parameter, int x, open close bracket, which indicates that the first argument is a pointer to type int, comma, represented by parameter x. Write the function declaration and header as shown. Int largest, open bracket, int asterisk x, int y, close bracket, semicolon. This is equivalent to the first form. Both int x, open close bracket, and int asterisk x mean pointer to int. The first form might be preferable. The parameter represents a pointer to an array. Of course, the pointer doesn't know that it points to an array, but the function uses it that way. Conclusion. In this chapter, we have covered the following aspects of functions. Top-down approach of problem solving, modular programming and functions, standard library of C functions, Prototype of a function. Formal parameter list. Return type. Function call block structure. Passing arguments to a function. Call by reference. Call by value. Recursive functions. Arrays as function arguments.